Hello. Thank you for joining us today for the Ethernet Essentials for Lighting Networks webinar. My name is Carrie Pitts, and I am Pathways Marketing Manager. A few housekeeping items to keep in mind for the webinar. First, all attendees are on mute for the entire webinar. During the presentation, if you have any questions, please enter them in the question box in the GoToWebinar tool on your screen. There will be a Q&A section at the end of the presentation, so any questions you enter will be answered then. Any questions that are not answered will be answered via email within 24 to 48 hours after the webinar. So in this webinar, you will learn a few things, including the basics of Ethernet and lighting networks, keeping your network safe and streamlined, and common troubleshooting approaches. I would like to introduce today's speaker, Kirsten O'Leary. Kirsten is Pathways Director of Sales. She joined the company in 2020 and is based in the LA area. Kirsten oversees our dealer network. If you haven't yet met Kirsten, you will see her soon as our world is now opening up, and she'll be making more dealer visits. And Pathway will be at the next LDI and USITT trade show. Kirsten has a degree in theatrical lighting from UCLA. She worked as a lighting designer for local bands and was a lighting console operator at the LA Theater Center. She has had roles as product manager and product development at Strand Lighting and Colortran. Before Pathway, she was with Lee Filters as general manager. So from here, I'd like to hand the presentation over to Kirsten.
Thank you for that introduction, Carrie, and welcome to all. If you work in lighting, particularly with DMX lighting, but so far have very limited experience with lighting networks that use Ethernet, this webinar is for you. Another way to put it, if you use DMX repeaters and switches, but want to understand more about DMX gateways, nodes, and Ethernet switches, you're at the right place. Next slide, please. These days, we take for granted the way our devices like cell phones and laptops connect to networks in our homes and workspaces. It's usually seamless and automatic. Even the devices that manage our home wireless networks take minimal setup. In workspaces and schools, there are one or more trained IT professionals keeping large networks running smoothly. A lighting network falls somewhere in the middle in complexity. For sure, it does not take a degree or certification to set up and maintain a lighting network, but there are some basic concepts you should understand. Let me take you through it. Today, we're going to go through why we need Ethernet in lighting networks in the first place, the basics of the hardware and connections, how the data moves around the network, the basic network setup, and some security and troubleshooting. We're not going to really cover specific wiring rules or specifics about configuration or a deep dive into Pathscape software. And we're going to assume a basic understanding of DMX, although if you're new to that too, the basic concepts of Ethernet will not be lost on you. So why Ethernet in lighting networks at all? These days, we need to move on from just repeaters and splitters because the lights are more complicated and using a lot more DMX slots. If all the lights were just 4 parameters like RGB, W, red, blue, green, white, that's only 4 slots of DMX, and you can get quite a ways just with DMX. But these days, some of the fixtures are taking up to 30 DMX slots. There are some that take even a whole half a universe, more than 200 slots of DMX just for one light. So there's a lot more slots being used, and putting DMX over Ethernet it allows you to use less wiring and have some flexibility in your wiring. So in the next slide, we can see a specific example of the differences. So this slide is a rather vanilla example of a system with 2 universes of DMX coming from a console. This is a pure DMX system. And let's say it needs to get to 5 lighting locations. So with this system, you have a control console with 2 DMX coming out the back and 2 optosplitters or repeaters, and then out to the lighting locations. So the blue wiring would be DMX universe 1 going to all the places. The red wiring would be universe number 2. And as you can see, that's quite a bit of wiring, but that's how it would get done in a pure DMX system. Next slide. So in this slide, I don't know about you guys, but I see kind of both at once. I hope you can see just the next slide. Yeah, so the purple wire is now an implementation of DMX over Ethernet using gateways and a switch. So in this case, the console, the controller, outputs the DMX over Ethernet on one wire. It goes into the Ethernet switch, and then the Ethernet switch also connects to each of the gateways. So instead of double wiring running to each 2-port gateway, it's a single cable running to each gateway. So it's half the wire, which is great. Additionally, on the next slide, we can see that this offers an opportunity for expansion in the future. So if you need to upgrade your system or you get more complex lights and you need 4 universes or more, you can still use the same one wire. And then you can tell those gateways to actually manage different universes. You're not just limited to universe 1 and 2 on each wire. You can change that down the road. So hopefully you can understand the clear advantages to using DMX over Ethernet at this point. But on the next slide, we'll see that you should keep in mind many applications actually use a combination of both. From left to right on this screen, we're showing some devices that are DMX over Ethernet only, a controller and the Ethernet switch. And then, of course, the gateways are translating the DMX over Ethernet to just DMX that would go out to the lights, or there might be another repeater after the gateway to distribute the DMX just as DMX. And that just might be a better way to solve things or an additional way to solve things. It really depends on the job and what the scope of what you're trying to do, but it is quite common to have a mixture of DMX purely distributed and DMX over Ethernet distributed as well in the same system. So next slide. So let's back up a little bit and talk more generally about Ethernet hardware. What is a device that connects to a network? Exactly, it's called a node. A node can be hardwired or wireless. And some nodes in everyday life you might see are a PC, a printer, a cell phone, a switch, a wireless access point, or a nanny camera. Now in the lighting world, the equipment you might see that are nodes are a lighting controller, such as a Pathway Cognito, a DMX over Ethernet gateway, such as a Pathport, a switch, such as a VIA, or a router, such as an E-Link. Now let's be clear. DMX optosplitters are not nodes. They do not have Ethernet connectivity. They're just DMX in, through, out. So they're not really part of an Ethernet network in and of themselves. Next slide. So this device is a switch. In case that wasn't clear in previous slides, we at Pathway deal in the hardwired world. It's the most reliable way to go. And to know more about those hardwired connections, we've got this little slide where you'll see on the left this particular switch. It happens to be DIN mount. We also offer rack mount, but it's got some connectors that are copper, which are what you're probably used to seeing in racks and whatnot with RJ45 connectors. And then there's also some slots that are SFP, which could be fiber, for example. There's some choice in the selection of those ports, but we can talk about them generally as copper or fiber, and those are options. And it depends which ones you use, depends on how much data you need to push around. So let's get into that a little bit. So it's all about the port speeds. Copper typically supports, is specified. Those ports are 10, 100, or 1000 base T, also known as megabits per second. And 1000 10 base T is the same as a gigabit, or 1000 megabits per second. So that if you see the different terminology, different places on the spec sheet, that's what it's relating to. And then a fiber connection can be a gigabit or 10 gigabit typically. Of course, always things are getting faster, right? So, we'll come back to this slide in 10 years and see what the specifications are in the world. To put that into practical terms, we'll look at the next slide. So how much port speed do you need in a lighting network? If you calculate that 0.25 megabits per second per DMX over Ethernet universe, don't mean to get into physics here, but we're just trying to break this down into understanding about port speed and what you need and look for in your system. So a 10 megabit per second port can handle 40 universes, and so on down this chart. So as you can see, a 10 gigabit port speed can handle 40,000 universes. It's quite a lot. But this day and age, really, there are applications that are using thousands of universes regularly. Next slide, please. And this table sort of expands on the idea. We get asked a lot, what sort of category cable should I use? And this kind of breaks it down. As you can see on the far right, there's listings of the most common Cat 5, 6, 7, 6A or 7. It's probably a pretty affordable cable for the application, but again, tie it back to the type of equipment you're using, the specifications of the port speeds on the equipment, and that'll line you up with the type of wiring you need to plan for. Okay, next slide. Okay, so if it wasn't evident in prior slides, I just want to reiterate that the hardwired connections are in a star topology. So the heart of it is a switch. And that usually what we see out in the field is most devices connecting to the switch with a copper connection. Next slide. If you wanted to expand the system out, you can connect from switch to switch with copper, or you could connect from switch to switch with fiber. Fiber has an advantage of having a longer span in distance, and that's why some people choose it. Copper is much less expensive and easier to find, easier to wire. But this is an example of expanding out of topology on a network. Next slide. Okay, so the point is you're not daisy chaining from device to device in an Ethernet network. You're always connecting back to a central something. And on the next switch slide, we can see if you relate it back to your home network, it's the same concept on a wireless network. You're not, again, connecting from device to device. If your laptop is connecting to your printer, it's not actually connecting directly on a Wi-Fi network. It's going through a wireless access point. So you can see this same topology that's wired, but with wireless, you just cannot see the wires. All right, let's talk about how data moves. So on a lighting network, there's some three typical delivery methods. Broadcast is one way of sending information where the controller is telling the lights to turn on. In this delivery method, data is sent everywhere. You could think of it as skywriting or the email equivalent of spam. the controller just puts out on the network for all devices to see what it needs the lights to do. ArtNet is an example of a protocol that uses the broadcast delivery method. Audio, video call streaming, they all tend to be broadcast. And it puts the burden on the gateway processors to manage what data they want to see and don't see. So it's very loud. Let's think of it as a very loud spam-like sort of delivery method. Next slide. So another way to send data from place to place is from a specific address to a specific address, kind of like sending a certified letter in the mail where you know who sent it and they know you got it. It's known as unicast. TCP stands for Transmission Control Protocol. And it's not super efficient in lighting because you've got the controller who's got to, send it directly to the person and be aware if the data got dropped, and that's a lot of processing power. Instead of on the gateway, it's on the controller. So that's not what is ideal for a lighting network either. On the next slide, we can see kind of the best of both worlds, where the delivery method multicast, or UDP for user datagram protocol, is like sending the message to, you know in advance you need to send it to multiple addresses, so it's more efficient than unicast, but it's not as loud and spam-like as broadcast. So SACN can do this on a managed network. We'll get into that a little bit more later, but let's just proceed with the idea that multicast is a really efficient way to move data around a lighting network, and talk a little bit about more how that happens. Next slide. So to get into the nitty-gritty of it just a little bit, the nodes on a network, how do they know if you're trying to get the data from one place to another, from device to device? How do they know they got it? How do you address that? Well, each device has a MAC address. It's a unique identifier assigned to the device. It is like a fingerprint, like your laptop has one, a gateway has one, a switch has one, Bluetooth and Wi-Fi and Ethernet all use them, but it's fixed. It also includes the manufacturer's ID, but if you think about it, just like we don't use our fingerprints to send letters to each other because it's very unique information, it's not super efficient to be able to get the information from place to place. Like if I move, poor mailman who has to try to find where to send my mail. Instead, we use an address, and as I move, I have my fingerprint, but my address changes. And the same concept is true for devices on networks, because most of our network devices in our lives come and go off different wireless networks, and our addresses need to change, and we're not found based on our MAC addresses that are hard coded to our devices. So on the next slide, we'll see that this is where IP addresses come into play, where the controller has an IP address for a device, and the devices are distinguished in that way. So it's more efficient than, say, the fingerprint MAC address methodology. And on the next slide, we can see a little bit more why. So here's an analogy for the anatomy of an IP address. The IP address has 4 sets of digits separated by dots or periods. There's specific rules about what those numbers can be, but just generally speaking, from left to right, if you can compare it to the address on an envelope, an IP address numbering is from least specific or to more specific. So let's say the red numbers could be equivalent to a state on an envelope. The blue numbers could be the city, the yellow could be the street, and the green could be the house number. So if you think about it that way, you can maybe look and see that, how if you look at your devices on your home network, you can see how, they all maybe have the first, they all have the first 3 numbers that are the same, or maybe the first 2 sets of numbers that are the same. And as devices come and go, they get, it's like moving in and out of a house. They get new addresses depending on the network. The other piece of this is something called a subnet mask, which identifies the size of the pool, shall we say, or the size of the mail van. So depending on how you set up the subnet mask, you can have like a little truck that just goes to Main Street in Burbank, or you can have a bigger truck that handles all the mail in Burbank. So broadly speaking, that's how you can think of a subnet mask, and an IP and a subnet mask work together. There's a lot of resources on the internet about those topics and the rules. There are specific rules, so it's much too much detail to go into here today and now. So, but I encourage you to look into that now that you have sort of a basic understanding of IP addresses and subnet masks. So next slide. So where does a device get an IP address? There's 2 ways. You can either go into the device settings and set it to be manual or static, and depending on the operating system of the device, a Mac versus a PC versus an Android thing, who's making the equipment. There's all different ways. There's no really way to say this is the way you do it. Just you look in your, generally saying you look in your network settings and see if it's manual or static. Most often it's something called a DHCP server that your device relies on to get the address, and that allows it to easily move from network to network and pick up its IP address as it moves around the world. So DHCP stands for Dynamic Host Configuration Protocol. And as it so happens, the VIA switch products have a DHCP server. So that's a resource that can be used by devices coming on and off a pathway network. Next slide, please. So we just mentioned VIA switches. Let's talk more about switches in general. There's 3 major types you can think of. There's your typical unmanaged switch. You could go to your office supply store down the street and pick up a really inexpensive unmanaged switch, and all it's going to do is anything connected to it, whatever is connected, can either send to or receive all this data that's going in and out. It's sort of like a splitter. You can think of it sort of that way. It's like whatever comes in goes out, except splitters are related to just one DMX universe, and the switch will just pass through whatever comes in and out. It doesn't really think about things if it's an unmanaged switch. A pre-managed switch has some configuration options, but it's not something a user would have access to change any of those things. If something should change down the road with your network, the switch is pre-managed, and if it's good for that day, it better be good for all the days, because there's not much you can do about it. Managed switch, however, is one where there's an ability for the user or the network administrator to go in and change things as needed, depending on if the needs of the facility change or the show change. There's some sort of software to go in and make the updates you need to keep the system running smoothly. Some, like the VIA switch, even have a front panel where some of that configuration can be done just without even opening up a PC. You can check out some of the settings, and entertainment grade switches, it's great to have that. Again, you don't, in other managed switches, you need to actually go to school, like Cisco school, to get a degree, get a certification to be able to know how to work with that switch and manage it. So that is an option that is often in the entertainment industry, but it's not super user friendly. And there are other entertainment switches out there that are managed and have a lot of great features and are much easier to configure and work with. Talking just briefly about PoE. PoE is a way for the connection to not only carry data but power on the copper. So way back on one of our first slides when you saw the 2-port gateways connected to a switch, remember that there was a 2-universe system with 5 lighting locations. Those gateways were PoE, and so the switch had to be PoE, where the switch can send power to the gateways, so you don't have an external power source for those devices. So check out the specifications of the switch and any devices you connect to it, and make sure that the PoE specifications are aligning between the switch and any powered devices downstream. Okay, let's take a little poll. Oh, wow, interesting. Looks like the majority of folks are using unmanaged switches. Something I didn't mention previously is, unmanaged switches can be a good solution. They can also work at first, and then something could slightly change in your network and things might not work. So be aware. With an unmanaged switch, you can't really tell why. There's no, as I say, it's sort of a black box. You can't dig in and figure out if the switch has all of a sudden stopped allowing traffic it used to allow, especially broadcast traffic. It considers that it could be like a security risk, and it shuts it down. Even from the same manufacturer, from one batch to another of switches, a switch you used to know and love that was unmanaged, a few months later, they might have changed some component and they don't think it matters, but it matters on your lighting network and causes problems. So anyway, there we go. Okay, back to the slides. Great. Okay, so on a managed network, you can set up the system to manage the data, and these are some really great tools you can apply, and I hope this explains what benefit they are to your network. The first one we'll talk about is IGMP. It stands for Internet Group Management Protocol. So in this case, the switch is determining, which it keeps the data from going everywhere all the time and reduces the burden on the gateways that are trying to process all the DMX universes that might be coming their way. So again, use IGMP, and that will reduce the strain on the gateways. Next slide. In a lot of entertainment applications, there might be different types of data that run around on the network. And this is trying to give an example of, say, your sound department and your lighting department need to run data on a network. Also, probably in the facility, you want to do some file sharing. So if you just connect everything to everywhere, all the data is going to go everywhere, and that may, burden things in a way that makes the network less streamlined and less responsive. One way to solve it would be to buy distinct switches for each department, but that can be a lot to maintain, and you have to have a special patch bay, and then a certain port on the wall. You might want it to be a sound port one day, but maybe a lighting port another day, and maybe you don't have that flexibility if all the switches are compartmentalized in that way. So on the next slide, we can see if you implement VLANs, it's another way to say which IP pools are on which ports, and you can make the equivalent of having distinct switches, but just using one switch. And because this is something you can configure differently depending on your needs, using VLANs makes your Ethernet network much more flexible. Okay, next slide. Another way to filter where data goes is with a router, and we have an E-Link router. This application is showing an example of, say, you have a lighting network with switches and gateways in your theater, and then you have a guest visitor come in. Say you're, the local touring show comes through, and your theater is there, and you're the ones they use. Well, you can put an E-Link between the guest switch and your home switch, and then allow only certain network traffic to go between the two. So the guest person doesn't just plug into your switch and get access to everything. You can determine how the data is flowing between the two switches. Next slide. So if you have a managed network, you can set up your switches to create a redundant loop. Like before we were saying, okay, star topology, we're not going to daisy chain. It's not the way it works. So on the other hand, with a managed switch, you can, for the category, add some extra category cable, and therefore have a backup plan in case one of the links between your switches goes down. Next slide. So this is called EAPS, Ethernet Automatic Protection Switching. So it can heal a break, say between the second and the third switch. If that line goes bad, it can heal it in less than a 20th of a second. So there's not even a flicker of the light. It won't be noticed, and your network keeps running smoothly. The data gets where it needs to go. Next slide. And again, we did say that the topology should be star, and sometimes there can be a bad loop where someone plugs something in unintentionally and creates an unwanted loop. So on the next slide, if you configure the switch, a managed switch, to have rapid spanning tree protocol, it can detect and neutralize an unintended network loop. And you don't have to set up specific ports for this. So it's really useful for helping prevent an unintended system problem that you didn't even know could happen. Next slide. All right, let's talk about security a little bit. We all have network security in our homes, or we should, and the same should be for our lighting networks. This is a screenshot from Passcape, which is free software for Pathway for network configuration and monitoring. It's showing that there are password protected security domains, so you can group your network products in specific groups, and they don't necessarily have to interact with one another. I think it's probably more common that at a specific site there is one security domain for the whole site, but that can be password protected, and then you can have administrative access, and people can not have administrative access and see and monitor the system but be unable to make changes. The administrator can actually do all the changes that have to be done. There are front panel lockouts. As we mentioned, our devices have front panel displays, so it's easier to have access, but you can lock out those front panels. There's also software lockouts. It's actually in some states a law to have, things password protected. And we also have signed firmware updates, so you know that the software you're downloading is secure. When you're updating your products, there isn't a chance of some malicious code getting into your products. And in an unlikely event, we just close all the doors, so that can't happen. We have a full section on our website devoted to talking more about security if you haven't already seen that. And now it's time for another poll. Okay, so more people than not are concerned about network safety in a lighting network, so that's good. Let me explain a few of the tools we have, for seeing how your network's performing, and start to talk about a little bit about troubleshooting. Here's another Pathscape screenshot. You can quickly see if devices are on or offline, if you were logged into a security domain, or if there is a device that is not in any security domain that needs to be brought into the fold. And then some basic information such as the type of device, a name for the device, its IP address. All of this is available in Pathscape, which also allows the windows to be sorted and filtered to suit your needs. You can give specific names to the devices that make them easier to remember. So that can really streamline your troubleshooting. On the next slide, we can see even more parameters that are available in Pathscape, such as the link status, if the device is on or offline, the bandwidth it's taking, and we talked about PoE. You can also see the PoE load. We don't happen to see that here, but that is another statistic that's available. Next slide. So Pathscape is a monitoring and configuration software that's mostly used on site. There's a product called 6i. It's a partner of ours that allows for some great remote access of network monitoring. It's a secure internet link. It's as secure as banking. It can push notifications to your phone or your laptop if telling you if something is gone offline. Multiple manufacturers are partners with 6i. You don't get as much detailed information about your network as you would with Pathscape, but it can be a good option, and I encourage you to check it out. Next slide. Okay, some troubleshooting tips. Some basics on the network. If you're trying to troubleshoot a problem, unplug Wi-Fi devices. They can muddy the water. Use a copper connection to connect your laptop or other devices to the network instead. If you're troubleshooting and you have DMX radios, which DMX, wireless DMX radios, just shut those off as you're trying to, suss out where the problem is. Those radios can add a whole other layer of complexity and uncertainty as to what's going on in your system. Also turn RDM off. That can cause lights to flicker as well. So those are some basic troubleshooting. A few more. If you find that you've connected your PC and trying to boot Passcape and you can't really access all the devices, first place to check is your PC network settings, your laptop network settings. As we said, a lot of laptops run around the world using DHCP, so they can go from network to network and automatically pick up IP addresses and communicate with other devices on networks in an easy and seamless way. However, go ahead into your network settings and try changing that from DHCP to static, and then set the IP to these to 10.0.0.2, subnet mask 255.0.0.0 as on the screen. And that should give you the access you need to the devices in case you're having problems with that. Again, use copper, try not, trying to connect to the Passcape into your system with Wi-Fi just adds that layer of complexity. So check those network settings, give these numbers a try. And then when you're done, reset your laptop or PC back to DHCP after you're done with Passcape, and so it can run around the world and join networks in the way you're used to. Next slide. So like with your home devices, use Passcape software to keep the firmware of your devices up to date. Load the latest software, make sure that can help eliminate some problems on your network you're seeing. We have a function called ping. It can help you discover devices on a network. I encourage you to look at the Passcape manual and learn more about how that works. But if you're having trouble even with ping, please note you should disable antivirus and firewalls on the PC because they can prohibit discovery. So that's the content I have for you today. We have lots more info on these topics if you visit the Pathway website. Go to the Resources tab and specifically look for VIA videos. They have some great real-world examples of some of the features we've talked about with network management, IGMP, EAPS. Just go, there's a whole list of examples of how the work those things are doing and how it, how it would, what you would see on your network before and after implementing those features. We also have more information on network security. In the Products tab, you'll find Passcape software and manuals there. And just know that on all our product pages, you'll find the manuals down below the main imagery of the product, and there's some accordion style buttons to hit the plus sign, expand the menu, and see all the manuals you need for each product, including Passcape software. So thank you for your time, and now we're going to move on to the Q&A section of the webinar.
Great, thank you, Kirsten. And thank you to those who submitted questions. If you still have a question in mind and you haven't had an opportunity to enter it into the tool, you can do so now. We will answer as many questions as we have time for in the next few minutes. And whatever we don't get to, we will answer via email in the next day or two. So the first question I have here is, can you talk more about 10 gigabit capabilities? And I don't know if, Kirsten, we want to bring Robert into this conversation?
Let's bring in Robert, our surprise guest today.
Robert Bell is, Robert Bell, actually, will you introduce yourself, please?
Hi, I'm they call me Director of Product Market at Pathway Connectivity. I've been around with the company for the last 12 or so years, and I'm now in charge of products. So of course, VIA is a very important part of our portfolio, and as this convergence between video and 10 years ago, there was a convergence between video and lighting. And now people in the theater are realizing that there's a convergence between all departments. So there's rigging because tracking follows lights. There's audio because cues between boards, lighting boards and sound boards and all the rest of it. So more and more when people are building permanent installed venues, they build a network that is the entertainment network. And that's why Kirsten's talk about VLANs and stuff was so great. It's like, okay, let's separate it up by department. But when you have those tagged links that have to move video data and lighting data and intercom data and all the rest of it, there's a desire to do that at very fast speeds. And our VIA 8, VIA 12 switches all support 10 gigabit links, which are really cool. So on the SFP ports, the higher numbered ports of our devices, we have the small form factor pluggable, which looks like this in reality, and they support 10 gigabit links. So as Kirsten showed in her chart, 40,000 universes of DMX, or hundreds and hundreds of channels of audio, or multiple channels of 4K video. So you can use a fiber cable to connect, and fiber can run in the single mode, it can run 10 kilometers. In the multi-mode, like this guy here, it can run 500 meters. And you can also get copper versions of these guys instead of fiber that you can use Cat7 wire on. And you can also get these very inexpensive direct connect cables, which are about a meter long, that when you're having a rack and a rack full of vias, you can just direct connect on the back of them and then build your own little link there. So direct connect, fiber SFP, or copper SFP all support up to 10 gigabit.
Thank you. Another question we have here is, can you RDM over Ethernet?
I'll take this one, Kirsten, or?
Yeah, go ahead and take that one too.
Sure. Yeah, we have been doing it for ages. The Pathport, like the Octo and the Quattro in historic terms, or the Pathport wall mount, rack mount devices we have, DIN mount devices, all support RDM on the DMX output ports. So if you have a port which is making DMX to tell the lights to turn on and off, it can also in between say, hey, give me your sensor values, or I'd like to change your DMX start address. And of course, the other side of that Pathport is a link to your laptop, which is running Passcape. And that link is done over Ethernet. So yes, we could do Ethernet RDM. There is a standard afoot called E1.33, which is coming out of ESTA and ANSI, which will make that go not just from our Pathports to our Passcape software, but will allow third-party devices like other lighting consoles or other software like, say, ETC Concert, to also Passcape to it. But this is a work in progress. And a rule of thumb, just to remember, I stress that our DMX output ports support RDM. I don't know of any manufacturer that has an input port that runs over copper that supports RDM. Ours do not. So it's from Passcape to our Pathports is over Ethernet, yes.
Okay, I think we'll do one more question, and that is, do I need Cat6 or Cat7 wire?
Well, we did cover that in the slide, and Cat7 is not required in, as you saw, in most of those applications. Cat6, Cat5e. Robert, have I got all those right? Yeah, that's just fine.
There's a tendency when people are laying wire in concrete, they might want to future-proof it with Cat7. But remember, even 10 gigabit running on Cat7 wire is still limited to 100 meters. If you want to future-proof it, you can spend the extra money. If you're just doing a touring show or anything like that, Cat 5e, the cheapest, the lowest end version of it, can run up to gigabit. So don't spend money where you don't need to.
Great. Okay, well, I think that's all we have time for today. We would like to thank you so much for joining us for this Ethernet Essentials for Lighting Networks webinar. If you could please take a few minutes to complete the survey following this session, that would really help us out a lot. Thanks again. Enjoy the rest of your summer and have a wonderful day.